Hi guys, good morning. So in the last session, we have seen about the STP forecast feature. Okay, so about forecast, we know that this is a feature of spanning tree that allows you or that allows the port to transition directly from, like to bypass the listening and learning state and directly move to the forwarding state, right? And the forecast is configured on the ports where you are connecting the endpoints. Okay, so if you are using interface level, like on an access port if you're configuring. So you can say spanning tree port path, and for a trunk port, you can say spanning tree port path trunk. Okay. Then if you want to globally configure on all the access ports, then you can say spanning tree port path default. Okay, this is the command we can use. And if you're configuring it on a trunk port, then we can say spanning tree port path trunk. To disable your port path, we can use the command spanning tree port path disable command. Okay. So these are few of the commands that we can use. Then after the port pass, we saw a scenario where somebody can connect an unauthorized switch in the network, and if this particular switch has lower priority or lower MAC address, then this unauthorized switch will become what? The root bridge. Okay, which is going to change the STP topology. So this is not really good news for the admin, right? And that is the reason that we don't want any unauthorized switch in the network and we don't want any unwanted changes in our STP topology. Okay. So due to this, we use what? We use the BPDU guard. Okay. So what this BPDU guard is going to do? It is going to put the port in the error disable state. Let's say I have configured a port passed on the 0 by 2, right? So also this particular port, the same port I'll be configuring with BPDU guard. Okay. So what the BPD guard is going to do, BPD guard is going to put the port, okay, this particular Z0 by 2 port in the error disabled state if this particular PC will be sending a BPD. Okay. So again, if you want to enable your BPD guard globally, in that case, you can use the command spanning tree port path edge BPD guard default. Okay. So this is going to do what? This is going to bring your port or enable BPD guard on the port. Okay, on all your ports, it is going to enable the BPD guard. While on per interface basis, if you want to configure the BPD guard, in that case, you can use the command interface name spanning tree BPD guard. Okay, this is how you can use the commands. Okay, then we also configured BPD guard and we saw about the logs of the log related to the BPD guard, right? So these are the logs. We saw, right, that when you configure BPD guard and BPD is received, so the port will be moved to error disable state. Okay. Then once the port moves to the error disable state, the port will not come up automatically. Okay. The port is not going to come up automatically. So one way is you can manually bring it up by giving the shutdown and no shutdown command. Okay. This is one way to bring up the port. And second way is to dynamically or automatically bring the port up. We can use the error disable recovery command. Okay, we can use the error disable recovery command. So you can say error disable recovery cause BPD guard. Okay, then you can say error disable recovery interval, and then you can mention the interval. That okay, after how much amount of time the port should automatically try to recover. Okay, so these are few ways, or you can say these are the two ways you can bring your port up. Okay, either manually or automatically. So these are the commands. Now, another way we will see, like even when you enable BPD guard, right? Okay, so continue follow the same. So Now, if you consider, so if I consider this scenario, right? Now here, if I will consider BPD guard, here if I consider BPD guard, here if I configure BPD guard, so what this BPD guard will do? This BPD guard is going to monitor all the incoming BPDs. That means any BPD that is coming from this side. Okay. So it will monitor the incoming BPDs. Okay. So if a BPD is received, it will put this 30 by 24 in the array diffusion state. Correct? Now the case is that okay, it is filtering the incoming BPD, but the BPD will still be sent on this side. This side, the BPD will still be sent. So that means anybody connected here, this particular host, will be able to gain a lot of information. Okay. Information about what? Information about, like what is the root bridge ID, what is the MAC address of the root bridge, what is the priority of the root bridge. Okay, what is the total path cost? That means after how many switches the root bridge is present. So like this, a lot of information will be provided in the STL package because your BPDU guard is doing what? BPDU guard is filtering only incoming BPDUs. It's not filtering outgoing BPDUs. Okay. So if you want that your outgoing BPDU should also be filtered, in that case, we can use what? We can use the BPDU filter. Okay. So if I will enable BPDU filter here, okay, if I will enable BPDU filter in this space, so what will happen? The BPDU filter is going to filter all the outgoing BPDUs also. That means this switch 3 will not advertise any BPDU on this side. Okay. Now, so we will see this thing practically in the lab. So let me start the lab. Now here, the
Okay.
Yes.
Even PC send BPDU packets.
No, no, PC doesn't send anything.
Only switch sends the BPDU packets, right?
Switches will send.
Thank you.
Now here, what I do is, and I'll connect two switches. These are the two switches. I'll connect them.
Ajay, can you talk a bit louder? Your voice is a little feeble.
Sure, sure. Okay, let me see what. Let's use a different microphone. Okay, how's the voice now?
Good.
Good. Okay.
Yes.
So we are connecting the two switches here. And let me just go and start the switches. Let's take an access of these switches. Switch 4 and switch 5. Now these two switches, what will happen initially, these two switches, both of them, they will consider that, okay, they are the root bridge. Then one of the switch will become a root bridge and another one will be a non-root bridge. Okay. So that means we are going to see one port as designated and one port as root port. coming up. Okay, so this is our switch 4. Host name switch 4. Okay. Then this switch 5. Enable configuration. Terminal hostname switch 5. So right now, if we take a look at these switches, right? So if I go and check show spanning tree, so by default, they will see that all the ports are up. We don't want all the ports to be up. We just want only one port. Okay, if I say show spanning tree. So here also it's showing all the ports. Now, let's go and shut down all the unused ports. So as of now, if I check here, okay. So if I check here, the port is what? Z0 by 0, and here also the port is Z0 by 0. So other than Z0 by 0, I'll shut down all the ports. So I'll say interface range Z0 by 1 to 3 and Z1 by 0 to 3. And I'll say shut down. Same thing I'll say here also. And shut down. So that we will see only one port that is of some use to us, that is being used. So now if I check do show spanning tree, so I can see that my switch 4 is the root bridge. You can see this bridge is the root and its port is the designated port. And switch 5, if I check do show spanning tree, so this is a non-root bridge and its port is the root port. Right now, this is the scenario that this particular port here, this is the designated port and this is the root port. This guy is the root bridge and this is the non-root bridge. Now, why this is possible? Because, well, like why this has been possible? This has been possible because, you know, your switch 4 and switch 5, they exchanged the BPDUs, right? These two switches, they exchanged the BPDUs. And because they exchanged the BPDUs, they came to know that, okay, somebody is superior and somebody is inferior. That means one of them is having a lower priority, which is basically switch 4 in our case right now. Okay, and that's why this became a root bridge. So if I want that, okay, they should not become a root bridge, so what I can do, I can go and enable BPDU filter on both the switches. So they will not send BPDUs to each other. Like if I enable BPDU filter on the switch 4, so it will not send a BPDU this side. And if I configure a BPDU filter on the Z0 by 0 of switch 5, so switch 5 will also not send. So when they will both not send the BPDUs, they both will consider themselves as the root bridge. And we will see that, okay, this guy port also will become designated port. Okay, his port will also become what? Designated port. Okay, so let's see. I'll go on switch 4 and on the interface Z0 by 0, I'll enable the BPDU filter. Okay. Before enabling BPDU filter, let me show you what all the information is present in the BPDU. although we have seen that what is the information present in a BPDU. So earlier we have seen this thing, right? That in a BPDU, we have information about protocol identifier, protocol version, BPDU type, flag, root bridge ID, root path host, sending bridge ID, sending port ID, messages, max age, hello time, forward delay. This much of information is there. But practically, if we see, when we capture the packets, so let's take a look. So if I go and capture the Z0 by 0 interface, okay, so you can see I have some configuration BPDUs. Okay, so if I open the STP here, you can see I have protocol identifier, STP, protocol version, spanning tree. BPDU type is configuration BPDU. There are some BPDU flags, that is whether it is TCN or like TCN acknowledgement or topology change. So no, this is a configuration BPDU and it does not have a topology change flag set, right? Then what is the root identifier? So if I expand it, the root bridge priority is this one, the root bridge VLAN is this one, and the root bridge MAC address is this one. Then what is the cost to the root bridge? So the cost to the root bridge is 0, right? Then after root bridge identifier, okay? So in the bridge identifier, we have the information about the bridge ID, VLAN, and the system ID. That means the MAC address of the local switch, the sender switch. Okay. Then we have port identifier, we have messages, we have message timer, which is 20-second hello time, 2 seconds, forward delay time, 15 seconds. This much of information is revealed in a BPDU. So if you want that, okay, all this information should not be revealed. In that case, we can stop sending the BPDUs. Okay. So right now you can see these BPDUs are coming from, this MAC address 5000004 and 00. Okay. From this switch. So right now these BPDUs are coming from here. Okay. I can see again some configuration BPDUs are coming from here. So what I'll do is I'll go on the switch 4 interface gig 0/0 and I'll enable the BPDU filter. Okay, so BPDU filter also you can enable globally also, and you can enable on per port basis also. Okay, so first let's enable it per port. So I'm already on the interface gig 0/0 and I'll say spanning tree.
So you're on switch 5.
Oh, yes. You're right. I'm on switch 5. Interface gig 0/0 spanning tree BPDU filter, and I can say enable. If I hit enter, earlier I was continuously having STP packets. Continuously STP packets were there. Now I don't see STP packets coming. Okay. Earlier I was continuously having these STP packets, the configuration BPDUs, right? But now what is happening? That I'm not having a BPDU from this 04. You can see from 05, the BPDUs are coming now. And what kind of BPDU? You see here, this is a topology change. If you see here, TC means the topology change. The flag is set here for topology change. Okay. And all these STP packets, now you see they are coming from the MAC address 05, while earlier they were coming from the MAC address 04. Okay. And as of now, if I go and check the ports, so switch 4 earlier it was designated port. So now also it will be designated port only. Okay, this bridge is the root designated port. What about switch 5? Now switch 5 is not receiving any BPDU right now. And you see, switch 5 is also considering itself as the root bridge. It says that, okay, this bridge is the root and my port is also designated port. Why? Because the switch 5, earlier it was receiving a BPDU from switch 4, which was inferior. That means which was having high priority, lower priority or lower MAC address. But now switch 5 is not receiving anything like that. So now both of the switches, they are considering themselves as the root bridge. You can check here. When we checked on switch 4, it says this bridge is the root. And when we checked on switch 5 also says this bridge is the root. This is how your BPDU filter works. Is it clear?
Yes, sir.
All right. Okay. And let's say now what I'll do is on this interface, right? Right now, switch 5 interface is not receiving a BPDU from the switch 4. So on the switch 5 interface, if I will enable port fast, let me enable it. Interface gig 0/0. Okay. Okay. So on this interface, if I will enable port fast, if I say spanning tree, port fast. Okay, I have enabled it. Now, if I go here and if I disable the BPDU filter, okay, so again, what will happen? I will start having the BPDUs from the 04 MAC address. You will see. I have BPDUs from the 04 MAC address. Correct? Now switch 5 will receive what? Superior BPDUs. The switch 5, it is going to receive what? Superior BPDUs. See here. Now all these BPDUs are coming from 04 again. And we should see a log here. If we check again, do show, okay. I have enabled port fast on this one and okay. I have made a mistake, slight mistake is there. So what I'm trying to do here is that let's say right now, again, I'll enable BPDU filter here. Here I'll enable BPDU filter. Okay. As well as I'll enable what? Port fast. Both the things I'll enable on this port. And then if this side, okay, if this guy is going to send a BPDU, okay, that time you see what is going to happen. That means we know that BPDU filter does what? BPDU filter is going to block outgoing BPDUs. But what if a BPDU is received on a port where you have configured BPDU filter? In that case, what? BPDU guard does what? BPDU guard is going to put the port in the error disable state. But what your BPDU filter is going to do? That is something we are going to check. So let me remove the port first. Okay. And here I'll enable the BPDU filter and I'll enable the port fast. Okay. Now, once I enable port fast here, and if the switch 4 receives a BPDU, in that case, what is going to happen? That is, we are going to check. So I'll shut down this interface and I'll no shut down this interface. Now we will see what is happening. We didn't get the log of the interface going down and up. Videos are being sent. Do show running interface x0/0. So we have BPD filter here. We have port fast here. Okay. To show interface status. And this is connected. Now the interface should be down. Interface is down. no shutdown. The interface is up. Okay, here let me shut down and no shut down the interface, because sometimes the logs, they will take time or they will just not pop up. That is the thing. Shut down and no shutdown. Interface is up. Like same like BPDU guard, we should also get BPDU filter logs. Mhm. Okay. Let's try to do one thing. Default interface gig 0/0. Here I'll not configure anything, and I'll configure both the things here. Interface gigs 0/0. Spanning tree put first. Spanning tree. BPDU guard enable. Oh, sorry, not BPDU guard. We have to enable BPDU filter. BPDU filter enable. And then shut down. No shutdown. Interface change state to up. This side all okay. Do show spanning tree. Interface gig 0/0. Detail. So we can see the BPDU filter is enabled here. Okay. And the port is in the port fast mode. That is also fine. Just let me check. There has to be logs. BPDU filter logs. These are the logs. These are not the logs. Okay, so that means BPDU filter is not going to generate logs. Only BPDU guard generates it. Just a moment. There has to be a way to check it. Okay, so might be this will not generate logs, because you can see the BPDU sent. So there are no BPDU sent here. Okay. Again, if I check, so spanning tree interface gig 0/0 detail. So one thing you can confirm here, that this BPDU filter, right? It is neither sending the BPDUs nor receiving the BPDUs. Okay. Both sides it is not allowing. Okay. Neither sending nor receiving. That means it's not at all processing the BPDUs. Directly drop. Okay. And Another thing is your port is not going down. Okay, although we are not able to see the logs, there has to be a way. Debug spanning tree all. There has to be a way. Okay, some messages are there. So I think I can ask for details. Do we have option for detail? No. Encapsulation. These are all spanning tree messages. Let me check. General BPDU. Topology events, root events. Spanning tree BPDU. Okay. First, let me check about BPDU. Interface, yeah, this command we have used. Spanning tree summary. Show logging include BPDU. Debug spanning tree BPDU filter. Debug spanning tree BPDU filter command is not there, right? This command is not there. Events we can check. That is for the topology events. This will also not work. Root MSTP. What about general? Ether channel BPDU handling. Okay, I have used no. Fine. If I say all, it's not giving much of a detail. Okay. So we just have information about, like we are receiving a BPDU, okay, from a ISR series. This is the MAC address. Okay, this is the protocol running, which is IEEE. That means PVST plus VLAN ID is 1. Okay. So these BPDUs are coming from STP. Okay, we are receiving the BPDUs. Okay, but they are not being processed. Okay. Let's check the logging command. Show logging. The same logs are there, debug logs. And if we filter, include BPDU, no, BPDU. No logs will be generated for BPD filter. This command is not there, right? If you check, show spanning tree, and we don't have the BPDU keyword. Sorry, debug, right? debug spanning tree BPDU. Okay, so if I do this also, I'm not getting anything here. We can just verify. BPDU filter, Cisco. We will just refer Cisco only. Importance of BPDU. This is from the community. Also from the community. BPDU filter logs. That is the show logging command. This is to check the Cisco logs only, not for BPDU filter. Show spanning tree BPDU. Port fast is there. Actually, what I was trying to show you is like, it should remove the port fast feature. Okay. Like if we check for BPDU filter only, this is what I was trying to show you. Let's go with this. Or it should be there in the book also. Let me open the Cisco book only. It's to be a way to check the logs, but it's not generating the logs. This is about the configuration. So you see, it will ignore the incoming BPDUs and will not send any BPDUs. That is totally fine. So it is equivalent to disabling the spanning tree. And it also, yeah, this is what I was trying to show you with the help of a log. That when you receive a BPDU on a port fast enable interface, it will lose its port fast status, disable the BPDU filtering, and act as a normal interface. Okay. LAN switching, spanning tree, RSTP, spanning tree protocol improvements, optimizing STP. Port fast is there. BPDU guard, BPDU filter, root guard. So this is about the BPDU filter. See, the BPDU filter feature is concerned with stopping the transmission and optionally the reception as well of the BPDUs on a port. Its behavior differs on depending how it is activated. If it is configured globally using the spanning tree port fast BPDU filter default, it applies only to edge ports. Okay. That means only the ports where your port fast is active. After these ports are connected to, they will start sending BPDUs, okay, each hello interval. However, if during the next hello interval no BPD is received from the connected device, the port will stop sending BPDUs itself. Okay. As a result, the port will send only 11 BPDUs, one immediately after the port is coming up, and then 10 more during the 10 hello intervals. Okay. So overall, if you check here, it will send like 10, 11 BPDUs. This is given here also in this total path goes traditional port fast BPD guard BPD filter. See here. With the global BPDU configuration on the port, it will send a series of 10 to 12 BPDUs. And if the switch receives any BPDUs, it checks to identify whether the switch is more preferred. Okay. So once you enable the BPDU guard globally, Okay, if you have enabled it globally, then what will happen? It will send around 11 BPDUs. And then after that, it will stop sending the BPDUs. So once you enable BPDU guard, right? I mean, not BPDU guard, BPDU filter. Once you enable BPDU filter globally, it will send 11 BPDUs. After that, it will stop sending the BPDUs. The port is still prepared to process any incoming BPDUs. And if a BPDU arrives at any time during the first 10 hello intervals or any time after, the BPDU filter will be operationally deactivated on that port. Okay, so the basically is the BPDU filter will deactivate and the port will start sending and receiving BPDUs according to usual STP rules. But there is not mentioned about anything about logs. BPDU filter operation on this port will be reinstated after the port is disconnected and reconnected. That means if you bring the port down and up. Okay. As usual, if the global configuration of BPDU filter applies to an edge port on which you do not want BPDU filter to be activated, you can examine the port using spanning tree BPDU filter disable. That means global mode will enable your BPDU filter on all the ports. But if you want a specific port not to be enabled with the BPDU filter, so you can manually give this command on that particular port. Okay. Then if configured locally on a port using the spanning tree BPDU filter enable command, BPDU filter will cause port to unconditionally stop sending and receiving BPDUs altogether. So these 11 BPDUs will be sent when you are configuring it in the global mode or you're configuring it globally. And if you're configuring it on the port specifically, then immediately it will stop and sending and receiving the BPDUs. Clear? Yes or no? But there is nothing about like whether or not it will be generating the logs. Okay. Clear? So BPDU filter will be deactivated only if you are configuring it globally. Okay, if we are configuring specific to the interface, it will unconditionally stop sending and receiving the BPDUs altogether. Okay, so in this case, it will not be deactivated. Okay, and if I go here, let's say, not this one. Let's say instead of configuring it on the I'll say show run interface gig 0/0. Then I'll say interface gig 0/0. And I'll say no here. Okay, then I'll enable it globally. Spanning tree, BPDU filter, span tree, port fast, BPDU filter. Is it possible that the command is not there? Edge BPDU filter, and then default. This is the command. I have enabled this command. Now, if this guy will receive a BPDU, so this time it is going to process. If we check do show interface gig 0/0, okay. Oh, sorry, do show spanning tree and detail. Okay, see. So now it is receiving the BPDUs also. And if I go to the interface Z 0/0, okay, if I shut down and no shutdown, and now if I check, okay, 0 sent, 2 received. Interface is up. Okay, so if you see here, if you see once I received, right? Okay, let me show you something. Not like this. Because here it is not telling you, right? Port fast has been, the BPD filter has been disabled here. So what I'll do is I'll shut down this port. Then I'll say exit. And again, I'll give the same command. Okay. Okay. And now if I will check, no spanning tree info is available. Interface gig 0/0. Okay, then I'll say no shutdown. Oh, immediately it will get disabled once it receives a BPDU. Already it received 12 BPDUs. So the BPD filter will get disabled here. Okay. So this thing, right, practically we cannot see, but that is the logic you can see here. Okay. Even in the Cisco, we can see that if we are enabling it globally after sending 11 BPDUs, okay, if it receives, like anytime it receives a BPDU, okay, see here. If a BPDU arrives at any time during the first 10 hello interval or any time after. So I think one more try I can do to show you. What I can do is I can go on the switch 5 I have enabled. So switch 4, I'll go and shut down the interface. Enable. Okay. Configuration terminal, interface gig 0/0, shut down. I have shut down this interface. Then I will configure once again. Okay. Configured. Let's check the interface characteristics. Interface gig 0/0, shutdown, no shutdown. This is done. Do show spanning tree summary. Okay, so you can see BPDU filter default is enabled. Okay. That is fine. Check whether it is there on the interface. Is it showing or not showing? So you can see here now, right now, BPDU filter is enabled. And how many BPDUs has been sent? 11 BPDUs. After 11 BPDUs, it will not send anything. Okay, it will send only and only 11 BPDUs. Okay.
So that time it was showing 12, right?
Where?
That before you could do this. Okay, 11 to 12 BPDs. Okay.
Yeah, between 10 to 12. Okay. But if you refer to the CCI book, it will specifically tell you. As a result, the port will send only 11 BPDUs. Okay, so to be specific, the number is what? 11. Okay. Clear? Now, we can see that it has sent 11 BPDUs. Okay. And now what will happen? If this guy will receive right now it hasn't received a single BPDU here. But once it will receive a BPDU, what will happen? The BPDU filter will be deactivated. Okay. The BPDU filter will be deactivated. So go to the switch 4. And if I say no shutdown, now this port will send a BPDU and this guy will get deactivated. Now if I check, we can see the BPDU filter has been disabled here. Clear? And now you can see it is receiving the BPDUs. Okay. But still it will not send the BPDU. Sending it still blocked. But BPDUs are being received. Clear? So major role of BPDU filter is that you want to stop sending the BPDUs. Okay, like if I define it in here, if we define BPDU filter, so we can say that BPDU filter is used to stop the sending of BPDUs through a switch port. Okay, and your BPDU filter, it can be enabled in two ways. Okay, we can say using the global command also and using the interface level command also. Okay, both the ways. Then if you have enabled in the global command, okay, in the global mode, then it will send 11 BPDUs. After that, it will stop sending. Okay. So I can say here, if enabled in global mode, it will send 11 BPDUs and then it will stop sending BPDUs. Okay. If a BPDU, so let me make a new point here. If a BPDU is received on a BPDU filter enabled interface, the BPDU filter will be deactivated on port and port will start receiving BPDUs. Okay. Port will start receiving BPDUs, but still sending of BPDUs will be blocked or stopped. Okay. This is how it is. While if we have enabled it on the interface, so in that case, what will happen? It will unconditionally, okay, stop sending and receiving the BPDUs. So this thing I will just mention it here. That if we have configured locally on a port using the spanning tree BPDU filter enable command, then BPDU filter will cause the port to unconditionally stop sending and receiving the BPDUs altogether. And the global command here, the command that is given is not going to work in your switches. Okay. So the command that will work for you is different. This is the command. Okay, the edge keyword is missing there. Okay. So here the actual command that is going to work for you is this one. This is the global command. I hope BPDU filter is clear. Yes or no?
Sir, global means
That means it will enable on all the port fast interfaces.
individually we need to enable or separate ports, right?
Then this command. Okay. This is the global mode command. This is the interface specific BPDU filter command. Understood?
Yes.
All right. So let me mention this thing also here. That using this command, the BPDU filter will be enabled on all port fast interfaces. Okay. Using this command, BPDU filter will be enabled on all the port fast interfaces. Okay.
So can you please, the second point, if a BPD is received on a BPD filter, can you once explain that part once?
Which one?
The second point.
If a
If a
BPDU is
BPDU
received on a BPDU filter enabled interface, the
Yes.
BPDU filter will be deactivated on that port and will start receiving BPDUs, but still sending off BPDUs will be stopped. So just now practically we saw this thing, right? That what happened? Let's say on this particular first switch, on this switch enabled globally, I have enabled using the global method. Okay. So once I have enabled using the global method, what will happen? That it will send 11 BPDUs. This side, it will send how many BPDUs? 11 BPDUs. After that, it will stop. Okay. After that, it will stop sending. So after 11 BPDUs, it will stop sending. Okay. But what is the thing that if during these 11 BPDUs or after these 11 BPDUs, if this switch is sending a BPDU, okay, if this switch 4 will send any BPDU, what will happen? This BPDU filter will get disabled on this port. Okay. So here, if a BPDU is received, then what will happen? Your BPDU filter will be deactivated. Okay. The BPDU filter will be deactivated, and then this port here, this will start receiving BPDUs. Okay. Stop sending here. Okay. And receiving. Okay. So that means after 11 BPDUs, this particular port will stop sending and receiving BPDUs. But once the BPDU is received on this interface, if any BPDU is arriving on this interface, then what will happen? BPDU filter will be deactivated. So it will sending is still blocked, but it will start receiving the BPDUs. This is what is happening right here. You can take a look. In our configuration, you can take a look that I sent 11 BPDUs only, and still I sent 11 only, but how many I received? I received 283. Again, if I will check, still sent 11 only, but received 287. Why? Because my BPDU filter is disabled. I don't see the BPDU filter message here. But earlier, when I checked, as soon as I configured, you can see my BPDU filter was enabled and I sent 11 BPDUs and I received 0. As soon as I received the first BPDU here, my BPDU filter got disabled. Understood?
Oh, yes. And the port fast won't be changed.
Yeah, port
right?
fast
Because
won't be changed. I saw in some book that port fast should also get disabled, but here port fast is not changing.
But by default, if you don't add BPD filter or the
No, by default, BPDU filter or BPDU guard, nothing is enabled.
yeah, like without the configuration of BPD filter and BPD guard, it will convert right to designated.
Mm-hmm.
Like if there is a BPDU message, it will directly convert, right? If there is no configuration of BPDU guard and filter.
Yes, if there is no configuration, then again one of them will become a root bridge.
Okay.
Okay, but let's say if this switch 4 has a lower priority or lower MAC address, so switch 4 will become a root bridge. This port will become designated, this port will become root port. That is the default case.
Yep.
Okay.
Thank you.
So this port fast and filter, it has to be enabled on the
Same.
port, right?
Exactly correct.
Okay.
Okay. But still, if there is any port, let's say where you don't want to send BPDUs, so you can disable BPDU filter. I mean, you can enable BPDU filter on that port also. Okay. Without port fast also, we can configure BPDU filter. Okay, but mostly we will configure on port fast interfaces. Why? Because those are the interfaces where we don't want to receive or send BPDUs. Okay, we don't want to reveal information and we don't want any BPDU to come in. So that won't change our STP topology also.
So, but this port fast, again, you will use it
For
in the
PCs.
edge device only, because that will not
Yeah,
do
because-
any listening and learning, right? It will directly forward.
Correct. But there can be some scenarios where, the employees can try to be smart, right? They can bring up a switch and they can try to connect some extra systems.
Can that port be even a trunk port also?
Which port? Yes, we can configure port fast on a trunk port also.
Okay.
Okay. We have a command, right? Spanning tree port fast trunk.
Right.
Yeah. So we can configure it.
So,
But
okay, if that
one
port
more
is a trunk port,
Yeah, one more thing before you ask the question. If you are configuring port fast on a trunk port, it has to be connected to a single node only. Okay, this is the requirement.
no, repeat again, sir. What do you mean by single node?
Let me show you. See this. It says this command should only be used with the ports connected to a single host. We cannot use it when you are connecting two switches.
Sir, but we use trunking only to connect from one switch to other switch, right?
No, it's not mandatory. I can, let's say, inter-VLAN routing, right? Router on a stick.
Okay. Router on a stick.
Yeah.
Okay.
There are scenarios. Sometimes servers are also connected to a trunk interface. Okay.
So when assume that we have enabled trunking, that time when you have enabled port fast and filtering, then after 11 messages, it will disable, right?
No, it will not disable. Yes, if it receives a BPDU, then it will disable.
That is if that other unauthorized switch starts sending BPDU. Otherwise, it will allow.
Yeah, otherwise it will allow. So 11 BPDUs will be sent. After 11, 12th BPDU will not be sent.
So, okay, only BPDUs will not send, but what about the communications, the messages?
Communication will be there. Communication will be there. Communication wise, no issues, because this is not BPDU guard who is going to shut down your port or bring your port into error disabled state. Like if I check here, right? If I show you here, we can still go and check the interface, right? Do show interface status. My interface is still up and connected. So communication wise, there is no issue.
Okay, sir.
Okay. We are just trying to prevent any unauthorized changes in our topology. That's it.
Okay, sir.
Yeah.
So
Okay.
in simple term, we are using this port fast and filter not to alter the topology.
Yes, not to alter the topology. Okay. So a conclusion of your port fast, BPDU guard and BPDU filter is in one line. If I give you this thing, so I'll say that your STP port fast, first of all, used for end devices. Okay. Okay. Second thing, moves port directly to forwarding state. Okay. This is about port fast. BPDU guard monitors incoming BPDUs and blocks the port. In short, I'll say blocks the port if BPDU is received. And BPDU filter, what it does is, you can say, stops outgoing BPDUs. That's it. In the simplest terms, if I will say, BPDU guard is going to stop the incoming and BPDU filter will stop the outgoing. But again, there will be slight variations depending on, global configuration and interface configuration. But this is what you can understand in the simplest way. Okay. All right. Now, again, like I said, we don't want any changes in the topology. Okay. So we have another mechanism, which is known as the root guard. Okay. Port fast is done, guard is done, filter is done. Unidirectional link, I'll come to it, but first we will discuss about the root guard. Okay. So let's talk about root guard. I think it will be there in the book also. Root guard. Yeah. See, what is a root guard? So first thing is your root guard is enabled on per port basis. Okay. It ignores any received superior BPDUs to prevent this port from becoming a root port. Upon receiving of superior BPDU, the switch will put the port in the inconsistent blocking state, ceasing the forwarding and receiving of data frames until the CPU superior BPDU ceases. Okay. Now, again, in the simplest terms, if you want to understand that what is a root guard, the root guard is used to prevent unauthorized changes of root bridge. Okay, in the simplest terms, if I will say, so root guard is used to prevent accidental or unauthorized changes of root bridge. That means in your topology, no other switch should become a root bridge. That is what your root guard is. Okay, and root guard is enabled on the root bridge itself. Root guard is enabled on the root bridge itself. Okay, so like if we take example of our topology, okay, let me just so next thing is about root guard. Okay, so we can say root guard is used to prevent unauthorized changes of unauthorized or accidental. Sometimes, maybe we connected a switch by mistake. In the STP topology. Okay, so this is what a root guard is. Okay, server is down. Okay. So this root guard is used to prevent the accidental changes of root bridge. So what you can understand from here is, let's say this is our, again, STP topology, and this switch is the root bridge. So rather than this, let me take this one. Okay, so this switch is the root bridge, and these are the designated ports here, right? Now, what we will do on these both ports, okay, on both of these ports, we will configure what? Root guard. So what will happen now? Once root guard is configured, so if any superior BPDU is coming, that means any BPDU with the, lower priority, lower MAC address is arriving here, then what will happen? That particular BPDU will be discarded, and these ports, on whatever the port the BPDU is received, that particular port will be put to the error disabled state or inconsistent blocking state. Why? Because the root guard will prevent these ports from becoming root port. Okay, on whatever the ports we configure the root guard, it will prevent these ports from becoming root port. And we know that root ports are available only on the non-root bridge switches. And this switch cannot be a non-root bridge. So that's why this switch is going to block these ports. Is it clear? So how do you enable it? The command is simple. You have to enable it on per interface basis only. So you will say interface name. Then you will say spanning tree guard root. This is the command. Okay, spanning tree guard root. Clear? Now server is down. Let me check if it is accessible.
Sir, suppose I need to configure which one is always the root bridge. In that time only we can.
Yeah, that time only we can configure the root guard. Initially, when you will do the configuration, that time only you will configure everything, right? Root guard, loop guard, all these things. Everything you will configure initially only, because after that, when you face problem, that time you're not going to do the things, right? Yeah.
Suppose some other 50 switches are added to our topology, there may be there's a chance for changing the root bridges.
Correct.
So to avoid that type of situation, we can configure this one, right?
Yeah.
Okay, thank you.
Okay. Okay, so guys, the switch, the server is down. So now practically it's not possible. So let's wind up for today then. We'll do it one thing. Tomorrow we'll continue. Now still we have few things. After this root guard, we have unidirectional link failures. Okay. So where we will discuss about loop guard, UDLD. Okay. Then we have to see about, direct link failures and indirect link failures. So these sort of things. So like I said, this week we will go with the STP only. Then we have RSTP and MSTP also. Okay. Because right now without server, we cannot go with the practicals. Okay. All right, guys, then this is it for the day.
Thank you, sir.
Okay, guys. Have a good day.
Okay, thank you, sir.
Yes.